Alright, looking at the diagram over here, you can see that, remembering we measure from 0 degrees over here, we've got 0 degrees all the way over to here, and that is going to be A degrees. So that point P is at A degrees, so its coordinates are cos A sine A. If I look at just B, angle B, so that's again from 0 but only up to here. So this point Q is at cos B sine B. So if I take away B from A, I just get that angle in the middle. So this angle here, which is angle A minus B. So we're using this triangle PQ, let's say O, and we are going to look at the distance between P and Q two ways in order to get this expression that we want up here. All right. So you can see from the left-hand side, it's leading us towards the cosine rule, so we might do that one first. So let's use the cosine rule in that triangle of that angle. When we do that, we square these two sides, so we've got 1 squared, we've got 1 squared minus the side opposite, let's just call that PQ at the moment, so that's PQ squared, all over 2 times 1 times 1, so 2ab, so it's a squared plus b squared minus c squared on 2ab. So of course the bottom is 2, so I'm going to just put the 2 over here, so we've got 2 cos a minus b being equal to 2 minus pq squared. Now if I make pq squared the subject, I've got 2 minus 2 cos a minus b over this side. Alright, so that's using the cosine rule to find the distance PQ, or PQ squared. The other thing I can do is just find the distance between 2 points using Pythagoras. So we've got PQ squared is, and I've squared it so I don't need the square root. So the difference in the x's is what I need. So I've got the x's are cos a minus cos b, so the difference in the x's all squared, plus the difference in the y's all squared. Oops, that should be a sine. Alright, if we expand that out, we get cos squared a, we also get a cos squared b, but don't forget the middle term. We also get a minus 2 cos a cos b. I'm going to run out of room, so I'll put this one here. We're going to get a sine squared a, we're going to get a sine squared b, and a minus 2 sine a sine b. Alright, so putting all that together, you can see these two terms, cos squared theta plus sine squared theta, or cos squared a plus sine squared a is 1, and again, cos squared plus sine squared of the same angle is 1, so now we've got 2. Minus, the other ones are both minus 2, so I'm just going to factorize. Alright, so we get that nice expression there. Now both of these equations that we've got here are PQ squared, so if we equate both of those, we get 2 minus 2 cos a minus b equaling 2 minus 2, and we've got this expression that we wanted, cos plus sine sine. Alright, now they've both got a positive 2, so minus the 2 from both sides. We could also divide by minus 2 both sides, and we get the expression we were after. So we get cos a minus b being cos a cos b plus sine a sine b. So just practice doing that a few times to derive that formula.